Hey guys, Mr. T here. This is another video. This one is on, well, it's a Year 10 science practice motion test. So this is as close to the test as I would like to go, to give you an opportunity to review for it. In a test style rather than just a series of questions like I've given you in the previous 3 sheets. So, starting on 1, which force acts on a car's wheels that resists its motion in whatever direction it moves? I'd probably accept wind resistance, okay, but really, if anything's moving on a surface, the force that opposes its movement in the opposite direction is friction. Which law of motion states that an object at rest tends to stay at rest, an object in motion tends to stay in motion? So the law that talks about an object keeping on doing what it was doing is the first law, or the law of inertia. A unit used to measure speed, that's meters per second, because newtons is force. Who divides the 3 laws of motion? Well, they're Newton's 3 laws of motion. That's number 5, Kendall. So this is a Kanye West themed test. Hopefully you can handle that. Kendall runs to her dance class to arrive on time for lesson. She travels, those birds are really loud. She travels 30 meters east and then 18 meters west. What distance did she cover? So distance is the total length units of the trip. So that is 30 meters plus 18 meters. That's going to be 48 meters. Distance. What was the displacement? So now to think in terms of direction. 30 meters. She started going east, but then she went west in the opposite direction, so minus 18 meters. That's going to be 12 meters. So 12 meters east displacement. So the direction is given, because direction is important when we are discussing displacement, as it's a vector. Kanye West rents a private jet for the weekend, flies 750 k's from Adelaide to Melbourne, takes 45 minutes. What was his average velocity for the trip? Gives the answer in kilometers an hour. So average velocity, we're using the triangle, v, distance over time. So we're finding v, we need d and t. T is going to be 0.75 hours, because 45 on 60 is equal to 0.75. So remember to convert. So velocity is equal to the displacement, 750 kilometers, over time, 0.75. That comes to, on the calculator, 1,000 kilometers an hour. Kim and Kanye hiking in the Grampians. Take 4.5 hours to walk 27 kilometers. What's the average velocity? So it probably should be distance, because it probably should be speed, because I'm guessing that a trail wouldn't be perfectly straight, but whatever, we'll just deal with the question as it is. So the triangle, what was the average velocity? We're finding v. So velocity is going to be the distance, 27, over time. It's 4.5 hours, so 4.5. 27 divided by 4.5 is 6 kilometers per hour. Given the speed in South Australia is 110 kilometers an hour, I travel at this speed for 3.5 hours. How far have I traveled? So speed is equal to distance over time. I'm looking for the distance. So distance is equal to the speed times by the time. The speed was 110. The time was 3.5, 3.5. 110 times by 3.5. 385 kilometers hit distance. Kim is not a good runner. She can only run at 400 meters. She can only run a 400 meter race at a velocity of 4 meters per second. How long will this take her? So, how long? Cover the t. Time is equal to the distance over the speed. It's 400 meters over 4. It's It's 100 seconds. But it's asking for the answer in minutes and seconds. So 60 seconds in a minute, so 1 minute. And then from 100 seconds, there's 40 seconds left over. Alright, so that's the next question done. Moving on. Kanye is travelling along the Southern Expressway. I don't know why he'd be in South Australia. And was observed to cover 12 kilometres in exactly 6 minutes. Determine whether he was exceeding the 100 kilometres an hour speed limit. So, speed is equal to the distance over the time. He went 12 kilometres in 6 minutes, and that's going to give me 2 kilometres per minute. We're doing kilometres an hour though, so if you want to know how many kilometres an hour that is, well, how many minutes in an hour? 60. So if he travelled 2 kilometres in 1 minute, he's going to travel 60 times as far in an hour. So 2 kilometres an hour times by 60 minutes worth is 120 kilometres every hour. Therefore, he was exceeding the speed limit because he was going at 120 kilometers an hour instead. Find the acceleration object if it takes 2 seconds to increase its initial velocity from 10 meters per second to 25 meters per second. Acceleration is the final velocity minus the initial velocity over the time it took. The final velocity was 25. The initial velocity was 10. It took 2 seconds. 25 take 10 is 15. 15 on 2 is 7.5 meters a second. These birds are very loud. Kim and Kanye conduct an experiment using ticket timers. These Kim and Kanye's tapes describe the motion represented by the two following, that's poorly written, the two above ticker tapes. Well, Kanye's is constant speed. Why? Because they're evenly spaced. Kim's constant speed, evenly spaced again, but slower than Kanye's tape. Why? Because they're closer spaced, therefore they weren't going as far every tick. What is similar and different about the motion in both? Both show constant speed. And I already said that above, so yeah, this is the same thing again. Kim's motion is slower as dots are closer together. There is 0.2 of a second between dots on a ticker tape, 1 centimeter between Kanye's, 2 mils between Kim's. Find the speed of both trolleys. So let's do Kanye's here. Speed is equal to the distance over the time. Kanye's tape is 1 centimeter over 0.2 seconds. 1 divided by 0.2 is 5. So his was traveling at 5 centimeters every second. Kim, speed is equal to distance over the time. Hers went 2 mils. Two mils divided by 0.2 is equal to 10 millimeters every second. Because there's 10 millimeters in 1 centimeter, that's 1 centimeter every second. But the question is asking for it in meters per second, so we need to work out how many meters per second 5 centimeters is. Well, there's 100 centimeters in a meter, so 5 divided by 100 is going to be 0.05 meters per second. And this is going at 1 centimeter per second, so 1 divided by 100 is equal to 0.01 meters per second. Okay, so that's that question answered. Time, page 4. If the acceleration due to gravity is 10 meters per second, so we've gone over the fact that it's 9.8. This is using just a nice round time for you, a nice round acceleration for you. It'd be easy to calculate it. Calculate time would take the ball to be traveling at 15 meters per second after being dropped. So this is the acceleration, change in velocity, acceleration, time. We know the acceleration, we want to find the time, so it's going to be the change in velocity, velocity final minus velocity initial over acceleration is equal to, turn back a page, so the time is going to be, velocity final was 15, and just before it was dropped it would have been at 0. We don't know how long it took, but that's what we're trying to find out, and we know the acceleration was 10. So 15 take 0 is 15. On 10, it's going to be 1.5 seconds. Okay. Next, calculate the velocity reached after 2 minutes 20 seconds by a tram, traveling at 45 kilometers an hour, accelerating at 0.9 meters per second per second. Convert kilometers an hour to meters per second first, give final answer in kilometers an hour. So this is probably your trickiest kind of question to deal with. So it's going to take up a lot of space. 45 kilometers an hour. Let's convert. So if that's every hour, 45 kilometers, if I divide 45 by 60, that's going to give me how far I go in a minute, which is 0.75 kilometers every minute. Not on a meter per second yet. So if it's 0.75 kilometers every minute, if I divide it by 60, that's going to give me how many kilometers it goes every second. So that's 0.0125 kilometers every second. But that's in kilometers. So if I wanted it in meters, I'd times it by 1,000. 1, 2, 3. It would be 12.5 meters every second. So calculate the velocity reached. So we know the acceleration, we know the time. We're trying to work out the velocity reached. So the acceleration formula gives us change in velocity, and the change in velocity gives us the velocity reached. So velocity final is what it reaches. Take away what it started off at, 45 kilometers an hour, which we converted to this, 12.5 meters a second, is equal to the acceleration 0.9 times by the time. Now we're working in seconds, we need to convert this to seconds. 2 minutes 120 seconds plus 20 is 140 seconds. So V final, take 12.5, is going to be 0.9 times by 140, which is 126. The opposite of taking 12.5 from the left hand side is adding it, and so we have to add 12.5 to both sides. 126 plus 12.5, so VF is going to be 138.5 meters per second. We want the answer in kilometers an hour, so right now it's in meters per second. That's going to be, divided by 1,000, 0.1385 kilometers per second. If that's how many kilometers it travels in a second, times by 60 to get a minute's worth, and that's going to be 8.31 kilometers per minute. Then times by 60 again to get an hour's worth, that comes to 498.3 6 kilometers an hour. So that's a pretty damn fast tram, but we're just going to answer the question as it's given. Alright, number 15, Kanye and Big Shuck both roll balls across the lawn, applying the same force. Eventually, both balls come to a stop. Kanye says this is an example of Newton's first law, but Big Shuck disagrees and says it's not. Well, obviously, Big Shuck is a maths guy, so maybe he doesn't know his physics. Explain who's correct using Newton's first law. First law states objects in motion will stay in motion unless acted on by an unbalanced force. We cannot see, but friction is the unbalanced force and stops the balls rolling because there is no constant force pushing them forward. So, Kanye's correct. Alright, Kanye's right. It does show. Because you'd probably be guessing that Big Shuck is saying it's not an example because why did the balls stop? We pushed them. They should keep going because they were in motion. No. They will stop moving because friction is a force, even though you can't really see it. Friction is applying to the ball, stopping it from moving forward. There's no force. They pushed it once to get the balls rolling. They won't keep going because friction is an unbalanced force stopping them from rolling. And so it won't stay in motion. How could Kanye and Big Shaq get their balls to roll further without increasing the force applied? They could roll on a smoother surface, so less friction, less of a force pulling them back, or they could reduce the ball's weight. You only need to give one reason for this because it's only 1 mark. Last page, explain why it's harder to push an adult on a swing than a child. You can explain this in 2 ways. You can explain it with the first law, using inertia. Adults are heavier, so have more inertia, so would take a greater force to move. They would need a greater unbalanced force to get them moving because their tendency is to stay stationary. The other way you could do it is the second law, force is equal to mass times by acceleration. For a given force, if you rearrange force is equal to mass times acceleration, the acceleration is going to be the force divided by the mass. Adults' mass is larger, so m is going to be a much bigger number for an adult. So if force stays the same, the force that you're pushing the adult or the child in the swing, the acceleration A will be smaller for the adult as you divide F by a larger mass, the force will cause less acceleration. Right, so this is the working formula here. You, as a person, can push with a certain amount of force. If you're trying to push a larger mass, that number divided by a larger number is going to be a smaller number, so a smaller acceleration. If you push a smaller child, so a smaller mass, that same number divided by a smaller number is going to be a bigger acceleration. Alright, so that's why it's harder to push an adult on a swing. Alright, so hopefully that helps you out with your test revision. Hopefully you get time to do this and get ready for your real test. Alright, see you in the next video.